Hi everybody, good morning. I'm doing today Linux threat detection number 3. So threat detection 3. This is a follow-up to 1 and 2 previous weeks. This one is the last stage, cover the last stages of attack on Linux and learn how they look in system log. This room is premium, guys. From the types we can stand its reverse shell, previous escalation, startup, persistence, account persistence, and target type and recap. So basically, when the attacker is inside the machine after reconnaissance and get access. Now, introduction task 1. Not all Linux attacks are simple SSH brute force or crypto mining. Some are carefully planned target campaigns comparable to most advanced Windows breaches. In this room, you will delve into more complex manual Linux attack technique commonly seen in target intrusion and learn how to detect them using system logs. Learning objective of this room, learn how to reverse shell use in Linux intrusions, understand how the attacker escalate their privileges, explore the 5 most common techniques to persist on Linux. Most five. We'll see how many of them later on, and cover the unlearn technique through the system logs. Previous request is good to follow up the rooms like Linux threat detection number 2. Recall the second half of the tactic a little bit. Be familiar with Bash and Linux administration. Of course, this room about Linux. You need to do some Linux. They give us the lab. I don't like the split in the screen. You have the Ubuntu user secure and the IP. I'm connected through VPN. I'm inside the machine through SSH. So I'm already connected to the lab. Okay. Let's start this. Um, Early morning. Let's start there. The next one, task number 2, reverse shells. Attack convenience. Threat actor entering via SSH get convenient terminal with color, autocomplete, and control C support. However, not every bridge grants a full functional terminal. This is the one when you do CDF, you need to stabilize the shell. When initial access happens via an exploit or web vulnerability, the attacker may face limitation, buggy command output, execution delay, and timeout, rate limit, network, things like that. In this example, we'll gain access to the TryHackMe app and see how this limitation work in practice. So, for example, here it tell you this is a classic ping example where application is vulnerable to command injection. Vulnerable allow command injection. For example, now it show the Linux kernel version uname minus a. Attack limitation for need a prepend. Not really. That's part of the job. You need to add command after this. Command execute after delay, after ping. Can't use Control C or C command history or error. This one, if you, but you can get reverse shell. This why reverse shell? The to combat the limitation, threat actor establish a reverse shell. A session from a victim to the attacker a more convenient and often the only possible action to continue attack. You can create a bot reverse shell. This is TryHackMe room, shell overview room, but for now, the common one, the classic, the Bash one, we have the socket one, we have the Python one. Usually, if you go to attack box, usually we use this one. We have a site there, and the site is online, so you can have it in attack box or shell.com. You see, this is the classic one. Usually, I like the most of the one. This one work, RCM, this one you have you can also change the bash. You can do the basic different coding. Sometimes it get blocked, and then you can see the PHP one. You can see the Python, the couple of Python there. This one, this that usually what you use when you do attack box things. Now, detecting reverse shell usually straightforward. SOC type of thread treat the reverse shell as critical alert as they indicate that the system has already been breached, and the human threat actor is actively attempting to establish a shell and continue the attack. Luckily, they are determined and detectable and audited. Usually, if you make a clear audit D in Linux, you can catch them because, for example, you can search for socket. You can see, for example, the PID and the parent that trigger the socket, and then you can search for any, for example, here. Find its parent process and build the process tree so we can see where it came from, and then for example, why is using 79. Yeah, because this is a parent that triggered the socket. Or this one, we're looking for the original, so we're going up. For the command, you're going back, so you look for more and the PID. So sometimes this approach is if you're looking for the original of the attack. For example, here you can see the Python and the main. So this one, if you investigate in the original, you go up. You going down if you go in looking for the command. After the shell to the attack IP established, it's usually followed by discovery and other stages you learned in previous room, like who am I and things like that. For example, now here we're going back like the first one. You get detecting the socket because he assuming the attacker use socket. Where is the socket here? Usually don't use it. Socket, if a socket installed, yeah. I usually don't use socket. Okay, that's fine. Let's leave it for now. So here, when you get socket, you can see the PID of the socket is this one. Then you can do look for any other process that triggered part of this. That's why here we're going down. We're looking for the command. In this room, they tell us we have this IP. Open a tab. You need to go VPN to access this. And they tell I was playing yesterday. Where is and they tell us use this. So you already give us the application. Usually when you do this, you start the simple. And he said, let me make this. Uh, like I tell you this and this are not there, so you can because first of all you. Oh, I have them yesterday here. I was playing with it. Usually you start with a normal ping. You can go to my and of course give you this because the first question is already asking you what output do you see after the ping. This is the next question is the one that get me a little bit. He said, "What is the flag returned in the type try ping me response?" And I got to be honest, I got confused in this question because they said the response is just say this. I didn't know what exactly is asking for, and even I want to. Um, I did reverse shell, and because the room is concentrating now is socket, we can get a reverse shell. Let's see nc minus lvmp 1234. If I follow the room, because the room is talking about socket, we can use the socket. Uh, the IP of the attack box is why this one it's the IP of the attack box is 3175. 1 2 3 4. Of course, now we got this, and then that's my problem with it. Is like, and then what? You get that, you cut the main and things like that. That's fine. We can see we are in the op TryHackMe, so we have that. Let's exit this. I don't need it. I don't need the. So the question here is that is that this question is get me freaked out, because you just say, what is the flag returned in the try ping me response to west? Um, Usually you can access the file but still respond, or response to what? Okay, we have that env locally, but we also have access to machine, so I can just go to opt what, and I can do it, and I just cut the main, and if I read the code, you can see it talk about the flag, and the flag is already there. So the question is, if you read the code, if you read it, said, okay, the ping, you have that one is sorry, is not allowed. Check, we have, that's the problem. Their shell is equal true, and then if socket in target and attacker in target, so these are two keywords, socket and attacker, then return the flag. And if his exception, it means if the ping fail, you still return the flag. uh, so in theory, of course, I can just do this also from here. I can just cut main.py, and still I can see it from here. So the question, I don't know what they expect us to do. What is the flag returned in the try ping me response? The first one is set you my try. Is there any question here we left not? Um, we have the socket, the IP there, so we don't have any uh, even this example, it doesn't say, because as you say, you see the code is clearly, he said socket and this. So the only way for this to get, you need to put like socket, you just put two keyword there. You can just say socket in the title and just do it like that, and he give you the flag. So even if you do the ping 127.0.0.1, it give you that. And if I give it the wrong IP for the sake of argument, say test.com, let's put any funny numbers here. It still give me the flag. So as long as you keep the keyword sock, if you just put there, so even if you remove there, it will not give you the flag, unknown error. So basically this one is going here. Where's the unknown error? Unknown error. He got us he returned that. So if you put the attacker just that one, it's still. So guys, I'm not sure what exactly we're supposed to do here, but the flag you can get it, but I don't get the question. If someone knows, just let me know in the comment what exactly this question mean. What is the flag returned in TryPme response? Response to what? So the only way to trigger the flag is you need to have the socket and try attacker.try thm. Okay, let's for now, let's, this is the code, so I don't know. Now the next question is, look at the scenario which IP spawn a similar with shell via, and here it is, you access the scenario audit log using this like we did like previous rooms. You set in the scenarios. So let's switch to just go straight to, wow, SU do SU. What we supposed to do again? Home Ubuntu scenario. So we have that log. So we can do o search minus I minus F audit log. So basically this is our log. The question would say, which IP spawn a similar reverse shell via typing me up? Of course, now you need to look. You're looking for socket. You're looking for things. Now the assumption. Now let's search for the, because the room looking for socket. We can see one in the socket. So we have the socket. When there is a socket, you can see. We can just grab that one. Grab minus I. Proc title equal. You can see it's a socket TCP. We have the IP, the port 1337, as basically the same example of. It's not us, this one. No, don't tell me it's me. No, that's not me. No, it's a socket. So either it's a socket, or what else we can search. So we know it's. I think it's this one. That's not me. Yeah, you can search, of course, it is socket, you can search, because if it's bash, oh, bash will be too noisy. Let's try bash. What? It is a bash, yeah, but it's not, it's part of another one. Yeah, if this one, if you want to trace it, we need to go to the parent. Uh, 255, what is that 255 for? Oh, no, not, SU. So this is not a shell. This is one the guy. So basically, you can say safety is a socket. So the guy start with a socket. That's the IP of the person. So yeah, we can argue in that logic. Let's see. Let's see if what anything happened to this guy. Uh, let's get any IP of this guy. What exactly is doing? Yeah, the only IP is the shell. So you can see the socket reverse shell. So you can see, okay, let's for now we are cool in this part. So only this part, I'm confused with this part. I don't need to hint you. Privilege escalation base. Of course, now we got a shell like we did it before. Another obstacle for attacker is insufficient privileges. Initial access doesn't always mean a full system compromise, and web attacks and exploit often start as low privilege service user. This user can sometimes be restricted to a single folder because you cap straight, for example, where the app is, or have no ability to download and run malware. In this case, the attacker needs privilege escalation, which can be achieved through various techniques. The common one, of course, they can check, for example, a kernel to see an old version. For example, here is an old Ponkit kernel exploit. They can search for that we call it SUID flag. Usually, when you do check your environment variable too, check anything that have that, and then go to binary of the land and see how to exploit them. Then SSH keys, expose and protected SSH backup and things like that. Detecting previous escalation might be tricky because of how different it can be. There are hundreds of SUID. Where is the example? Oh, this is the site. Usually when you find an SID, you just go here, you come here and start searching. But that one is usually, it's more not too much real, because sometimes CTF they just add it to find or something with no reason. That's why I don't like root shells in most of the rooms. For example, detection. One, a spike in discovery command like ym ls, we need to start detecting this. For example, detection or a download to temp. Yeah, it's like download malicious file, like here in Ponkit, and try analysis from. And then we have a next one, for example, detection 3, data exfiltration with scopy, because they copy something inside the machine. Even if you don't know, for example, here an example, they give us the Ponkit example. A local privilege escalation vulnerability discovered in Polkit PKXX CVE 2021 4034. You can do all search my IMS X, you searching for that web. The Ponkit was launched by service user. Look at UID, you can see it was the user who launched it. Now we need to trace the origin. So if we want to trace the origin, we need to parent 24304, because it's very 2434. Why is looking for the, you already know the parent. Huh, this is not right. He looking for, yeah, he's searching for the parent of 2434, which means this one. And then the pocket spawn a root shell. Yeah, this is not right. I think it's a PID here, not a parent, because you can't have them both here. I don't want to complicate, but I don't think it's correct this. And then here you're searching for 24310. The threat actor continued the attack as a root user. Okay, this one after you get to root. Okay. Any case, going up and down to church. Let's do practice. We'll see if we can figure out this part. Continue with the try ping me scenario and find out what followed the reverse shell. We're still using this because the room is switching between this and then the machine itself. Let me show that 120 minute. Okay, I still fine. Which command line was used to look for the pass keyword file? Oops, forgot. What's the question again? Which command line was used to look for the pass keyword in files? What we supposed to do? A reverse shell. Okay, let's trace first the user. We know the user. Where is that socket things that we got? Let me not grab anything. So if you look at the socket part, whereas we have a couple of socket ways, we have the first socket. Remember, we're looking what it follow. We have we're not looking for the original. We're looking for example, 2543. This one I can't see. I always have problem with seeing. The parent is 2545. This one is 2543. You can see they look into each other. So this is the PID 254. So this is it follows part of the socket itself. So you can see the PID 254 is becoming a parent here. So, and this is a continue to the socket. It's also socket. I think that's how the socket work. So we have the new 2546, and you can see it's the same here. So if we want to look for the command, we can look for this PID 2546, but we're looking for all the commands that come from that process. So we can do what is anything that was launched from this. So because this is the original socket. Huh. Oh, I almost said my logic was wrong. Now we have everything that attacker is doing. This is the origin, all the command that this attacker did. You can see who am I. Let's do the classic grep. Oh no, suddenly I found them. Yesterday I was playing, I didn't find anything. Now I'm confused. Huh, why am I finding them now? Funny, huh? Let's do this. So we have who am I, we have ls, and that's the question is saying which command line was used to look for the passkey. The passkey. So which command line was used to look for the pass keyword in the file? The find search them. The question is asking to look. Find doesn't look inside the file. The find doesn't look. Who look is the grep. The grep will look for the keyword inside. So the grep is the one that look for inside the file. The find doesn't look what's the content of the file itself. So that's why we're using the grep one. Which command line was used to escalate privilege to root? Yeah, su root. So you can see su. Now I'm confused because yesterday I didn't see it like that. They all, and then we have then we have what? Looking at the detected.env file, what was the root password? Okay, where is this? Yeah, if you don't know where is it, you can just do the we can just do what the attacker did. Let's follow the attacker, what the attacker was doing. Let's do find this. Huh. Oh, he's looking inside this directory. This local. No, let's find where is that file is. If you don't know where is it, find inside dash name .env .local. But you can see where is it because the attacker will know where he want. He got SSH to the app. But if we do that, if you are lazy, you can find it there. So because we know the attacker was inside, got the shell to the app, so basically will come here. So we can go ls minus la, and that's the .env, so we can just cut that variable. Or we can do what the attacker did. What the attacker did grep. We don't need the r, we are not going to the directory. You can just do I pass and he looking for, he find that environment, so we can just do, okay, let's do what the attacker did. The attacker basically did this, minus r pass, he was inside that directory, so basically, and he found it there. That's what the attacker did. No, but because we did, no, attacker, he did find first, and then, yeah, that's what the grep pass. Of course, we can just do opt try.env, and we can get run the app from this user, root user, and password. And it said the file is no longer used because usually the env you need to remove it. Now I need to do the sanity check because I'm get confused because I think this we solved this one easy by tracing the root of the. Now the question will be how about looking for some funny stuff I found yesterday. No, it's clean now. That's the socket. Yeah, this is a lazy way because you just want to look for the old command. Oh, the other one, the problem I'm having is later for the other task. This one is clear. You can see the proc title. Uh, oh, that's what attacker did. Oh, bash. Who am I? Bin. TCP. Who am I? The socket. Find. Okay, so we got wall upon you. What's this one? No, this one is not the attack, I think. It's part of bash. In any case, we found what we need to find. Let's get to startup persistence task 4. Persistent Linux. Standalone Linux server can run for years without a single reboot and are often left untouched unless something breaks. Some threat actors rely on it and do not rush to establish persistence. However, those aiming for long-term access often set up one of two additional backdoors. As in Windows, there are many ways threat actors persist in Linux. Let's start with the most common ones. Of course, we have most of the cron is the most used in general. The cron and then the system default services. The cron job are likely scheduled task in Windows. Are like scheduled tasks in Windows. They are the simplest way to run process on schedule and the most popular persistent method. For example, as part of the big espionage campaign, IPT29 deployed a fully functional malware named Gold Max. You can see it in CrowdStrike blogspot. A blog. Why is it my network down? No. Early bird catches the whole observation from the Stola. What? Stola what? It's a long article if you want to read. To ensure the malware survive in reboot, they add the new line in the victim cron job file located at varspol cron. Yeah, usually the crons are part of var. Look, the classic one is the you find them in cron tab minus e. Oh, just do cron tab for now. Hello. Oh, them the oh, because of these gutsy things. Hey, let me use the SSH for the other side. My editor is not fancy. Let's use this one. SSH Ubuntu at 10.10 24891 secure Yeah, you can start with the user, usually cron tab. Don't what I'm doing wrong here? Cron tab. I don't like nano. Let's use what most people use. Okay, there is nothing here, so we can switch to root. Cron tab, cron. Oh, we can find something here. Okay, we got it. The other one is var spol cron, and you can do cron tab. For example, we have a user here. The other one, where they put the other crap? etc cron tab, etc the cron d. Why it's making noise? Cron.d. Sometimes you find them here, but not always. But any case, for example, here in vars pol cron, and usually depend on the user. That's where you find them. Another example is rock crypto miner after exploiting vulnerability in public facing service like Redis or phpMyAdmin. Rock download the crypto miner script from pest bin and install it in etc cron root cron job red canary blogspot. Note that 10 between each 10 minutes, this means the script will re-download every 10 minutes, likely to quickly restore its file in case of the IT team accidentally deleted them. Pausing with a cron job. Okay. What assist the services usually if you do it in Ubuntu, the services are ls etc systemd, and then you can find them in the system, and you can see a whole bunch of them. You start looking for which one last change or something, or the strange names and things like that. So which nowadays DNS SSH and nearly every web service are organized as separate a .service file located in library system D system usually this one where we are looking. With root privilege you can make your own services as can the threat actor. For example, the Sandworm group once created a cloud online service to enable it to its go get the malware to run on reboot. This Median report. A simplified content, or this one that's unit, you can description, they choose a name that fake description to mimic a trusted service, and then exec on start when it starts the service around that binary could get a malware discussed it as a trusted file. Detecting persistence. Now, how to detect them? In this room, let's focus on detecting the moment the attacker established persistent. Both cron jobs and system D saves are defined as a simple text file, which means you can monitor them for change. That's the key. We're looking for changes. So we have monitor change in cron job file, etc cron D. Remember we saw this. We saw the for each user. Spoil cron tab. Okay, where is that one? ls var spol. I don't have cron tab there. Maybe different version of Linux. Monitor change in system default exactly any change that happened here and time, and this is less common location. Where is the less common location? Let's see. In case there is a CTF, you can come here. Oh, this is known path. Monitor related process. If someone tried to open the etc cron tab the -e, we did not let's start enable things like that. For example, here you monitor the file for any change. Look for file changes inside etc system D, and then you can see the V there, and then look for a cron tab. Look for execution of cron tab command. In this example, in this task, try to detect two persistent methods by using ODT log. And now we switch into the machine. We're not using that log we did before. You might need to switch to root, so make sure you are root. One, detect, launch the persistent malware and get the flags. So which one, the question? So the second one is cron. So the first one you're assuming is the service. So let's do o search minus I um, minus first etc system. Now what we get, let's do the lazy because I can't really see proc title. So we have two change. We have a tax service. We have this bad r.service. TryHackMe is trying to play with us. It gets something from where HTTPS TryHackMe VM deployment. I got confused with that, to be honest. If you go to system D, and then we can go to that bed wherever system that bad things. The bad thing what it says is binary chrome plus x etc bar address start etc wherever config rule uh, room YAML wherever. But if you go to etc, there's no bad address there, so this one I think is dead end. The next one we saw is this one. Uh, the tax service TUX, and this is this one. Now we have a strange start, not strange library. It's so we have that var library is task. Okay, it's a Linux system. What permission these things have? It's running on the root. No, the question said we should run it. No, string command is not there. So if I run it, what exactly will say? Var library miss task. It tell me a good job find me. Where did I persist? Example folder. Remember where we found it? We found it in we found it here. And then we give us the flag. If you want a lazy way to do it, oh no, something. Oh, he gave me the T correct. Oh, TryHackMe is generous. Okay. Look, we can do this. S trace minus L. You can see if you want to steal the flag. Good job finding me. Where did I? Good job find me. Example, your answer. I don't know, because you need a correct answer to get it, so no, P13 doesn't. Press enter, no. Or we can do this, we can just do this if you want to get the flag, if you want to cheat, if you are lazy to if you find the binary, you can do xxd, and then you can do grep minus I TryHackMe. And that's the flag. TryHackMe hidden penguin. No, we didn't get all of it. Let's get all of it. Minus C5. That's the full flag. TryHackMe penguin, and that's in the second line. Huh. Okay, so we got that one. The next one is the cron. the cron, let's go there because my cron doesn't work that side. If you look now, we have user spin phonics. So we have that phonics things. Let me go. So it's user spin phonics. If we go there, same is an executable. ls minus la is running in the root. Now if I run it, he said, where did you find me? Where we did, because it's a cron tab, so where is this running from? We can control C. We can be lazy too. We can just do xst user spin phonics grep minus I TryHackMe flag, and we didn't get the flag. Okay, too much minus C3. That's the flag, but we can go to var poll and look for any cron here. We have a root cron, so if we cut it there, now we got the original file. So now this is where we found it. We don't cheat, so we don't do that. We can just run it and said we found you there, and then you will give us the flag. And we got the flag correctly, so we don't cheat. Okay, yeah, but that one, let me see if it's the same flag. th result circuit and reboot. Yeah, that's the flag. Now, account persistence. What we've been doing. Oh, this is startup persistence. This one, task 5, is account persistence. The previous task was mainly about making the malware survive a reboot, but what about persistent access? As an attacker, you might want to return to the victim in a month to steal more data, but don't leave any malware there. How can you maintain access without malware? It's all depends on how you entered in the first place. New user account. If SSH is exposed, the attacker may create a new user account, add it to privileged group, and then use it for further SSH login. The detection is simple too, as you can track the user creation event through authentication logs and then reconstruct the full process tree in ODD by starting with OD the PID. Okay, that PID things. Here they give us as an example. We can practice this one also when we are learning and practicing the same time. Don't do that cut things. I don't know why they keep doing the cut. You can grab straight to the machine. Here you're either looking for user R or user mode from var log auth log, and you can see here was a new group name was created. User add a new username, this one, user ID there. Of course we can check it in the password file, so it should see it because in the machine that's the user which was expected. And what we found there, so we find there backdoor SSH keys. Another account persistent method is to backdoor the SSH keys of one of the user and use them in future login instead of the password. You've already encountered this in Linux threat detection 2 room, where Dota 3 malware added its key to the breached user. This technique is difficult for IT to spot, as malicious keys can blend in with legitimate one. For example, adding SSH key backdoor to authorized keys, echo wherever you, that's what they do, echo to authorized key. It's hard to guess which key is backdoor. Yeah, because if you cut this, you can see them are strange names. So if you don't have record for this, you might get confused. By default, authorized SSH public key are stored in each user. That's new in the .ssh folder, and the file is new and authorized keys. So your best detection method is to monitor change for this file. Of course, as we did with the service, we do changes for this one. So if we apply our source here, and you can say or search minus I minus file change, what we doing? Or the folder .ssh authorized keys, and here will tell us we have some changes has happened. Where is it? The bash that cloud unit file. It has an Ubuntu keys there. Oh, this is the shell before. No, that's not the shell. Yeah, this is the root one. And then we have a Python the same. And you can see another one to change in the root.sh, the root key, the root directory. So you can assume, I'm not sure. Let's see what. Okay, we saw that. Application persistence. Imagine WordPress website where the web admin account has been breaches. With admin privilege, the attacker can add a backdoor. Example this is when known shell to the website and run commands through the backdoor. Let's see. This one is that shell usually. Oh, this one. Okay. To open and run command through the backdoor. No cron job or SSH keys required. Moreover, because the persistence lives in the application layer, or the D and system log often never see it. While up-level persistence is beyond the scope of this room, you should be aware that it is a possible and common scenario. If you verify all possible persistent technique, but malware somehow reappear after some time, one of the public-facing app might be compromised. If the app allows code execution in the system, the attacker can leave a backdoor inside the app without a need to persist directly in the OS level. So we can't detect in the OS level, okay. Now detect two more persistent methods in the VM backdoor user and SSH keys. You can use audit or an authentication log to answer the question. We already, which user was created under to a sudo group? We already did this. We already grabbed it from that, and we have a new user. Kochi added this user to a sudo group. So the answer should be this is the user. What file was changed to allow SSH key persistence? Okay, now this one we got authorized. Now, of course, we have which you can see it's a root file. What's the time here? The 10:55 40051. Oh, this is the latest, and this one. No, this is the Ubuntu one. This is today. That's mine. No, this is not our. This is the room 25th. This is something I did or something. So the file should be this one. I'm getting confused. I don't know what I was doing yesterday. Target attack and recap. Target attack in the Linux threat detection 2 the room you have explored hack and forget attacks such as cryptominer infection. They are automated, do not care about who the victim is, and rarely employ tactics like privilege escalation. However, there can be more complex and more devastating attacks that target specific companies or government. That's where you will need to learn techniques the most. Linux is entry point. Linux machines are commonly deployed as firewall, web server, mail server, or other public facing services. Even in organizations where 99% of the infrastructure is Windows based, a single compromised Linux server can open the door to a corporate network and result a big impact. That's why as a SOC analyst you need to know how to secure all popular Linux systems. Okay, what's this one? First, bridge the internet facing Linux server, TryHackMe Active Directory network, then use it to move. Linux as espionage. Linux machines can store sensitive information or be used in mission critical network and thus are often targeted by state sponsored threat group. For example, in this espionage campaign Symantec article, Kimsaki APT installed backdoor on multiple important Linux targets. Interestingly, they used system D service persistence, the technique you already know. Okay, so they use system D here. Linux in ransomware. Linux ransomware is on the rise, with a hypervisor becoming a primary target. Imagine the case your company run hundreds of Windows VMs, all sitting on just three Linux physical server hypervisors. If those hypervisors aren't properly secured, all corporate VM are at risk. For real-world example of how attacker breach hypervisor, check out Varnus out. Okay. That's true. It means if you have a Linux that is the main system and all this hundred of VM, so you can imagine if you target this one, you just ransomware payload. Okay, threat detection recap. After completing Linux threat detection room, you should understand that Linux system can be complex, but also critical asset to protect. Fortunately, now you can identify the risks and spot the most common technique across. Yeah, I hope the CTF rooms when they make these Linux things, especially Linux root share, not always using that nonsense binary things. Now let's do the question. Does Linux ransomware exist and impact on its nation worldwide? Yes. That's as we read it in the room. Should you learn, I don't know why there is a hint here. Should you learn Linux threat even if you're working with Windows? Yes, because of VMs. Conclusion. Through a series of scenario of real-world example, you explore more complex target Linux attack, how adversaries overcome access constraint, how they maintain long-term persistence, and what goals they pursue. Many SOC teams skip Linux monitoring, but now you know why it's dangerous blind spot and are prepared to detect complex attack chain in SIM or directly on the host. We hope the audit practice wasn't too painful. No, I like audit. Maybe it will be room this. And this is the end, guys. So this one because of my cron stories. This is my Gotsi Linux version one. It's not like the other Mac one. Still have issue when you scroll like that. Doesn't have that tab for scrolling. Uh, how about what happened to our so what I was doing again? This is the one I don't need it anymore. This one we did it a test. Uh, this is the ping app. The part I get confused on it. Thank you everybody. If you have question, let me know in the comment and have a good day.